Hey everyone, so today I will be telling you about the conservation of linear momentum. If you don't know what momentum is, go on my previous video named momentum, so you know how to calculate momentum, okay? So momentum is conserved. So the law of conservation of momentum says that when two objects interact, the total change of momentum of the two objects taking the direction into account is zero. Now, that means that whenever there is an interaction or collision between two objects, the total change of momentum, so if you do the momentum before and minus the momentum after, if you take the direction into account, because momentum is a vector, so in one direction is positive and in another direction is negative, this total change of momentum is going to be zero. So that's the same as saying that the momentum before the interaction equals the momentum after the interaction. So a good way to start a momentum conservation of momentum exercise is by writing that P, the symbol for momentum before, equals P, the symbol for momentum after, where before is before the interaction and after is after the interaction. And then you just get the two objects. So mass of the first object times velocity of the first object before the interaction plus mass of the second object times velocity of the second object before the interaction must be equal to the adding the momentum of the first and the second object after. So mass of the first object times velocity of the first object after the interaction plus mass of the second object times velocity of the second object after the interaction. So all that I did was adding the momentums for object 1 and 2 for before the interaction with a B and for after the interaction. And this is because momentum is mass times velocity. And again, in law conservation of momentum, because it's about momentum, momentum is a vector. Getting a sign wrong can cost you the rest of the exercise. And I will be showing you examples of that, not in this video, but in other videos, okay? So, before, I also have this on why conservation of momentum is cool. So remember, energy is conserved in terms of the numbers, so qualitatively. And I have here 12 amazing trick shots that have to do with conservation of momentum. So these are examples of conservation of momentum. I will add a link in the description, okay? Some of them also have friction and all that stuff. But basically, this is where this law is being obeyed, okay? The law of conservation of momentum. So let's practice some questions. I got these exercises from my QA. Pause the video, try the exercises yourself. Red are the easiest ones, amber more or less, and green are the most difficult ones. Again, pause the exercise or the video if you want to try the exercises by doing the conservation of momentum. Otherwise, I'm going to be giving you the answers right now. So, first exercise, a 0.5 kilogram trolley A is pushed at a velocity of 1.2 meters per second into a stationary trolley of mass B of mass 1.5 kilograms. The two trolleys stick to each other after the impact. Calculate the momentum of the 0.5 kilogram trolley before the collision. Well, momentum is mass times velocity, so it's going to be 0.5 times 1.2, and this is going to give me 0.6 kilograms meters per second. I didn't want to show the whole thing by now, but oh well. And then the velocity of the two trolleys after the impact. So again, what you're going to do is you get the long equation and substitute the values immediately below the equation. So, momentum before equals momentum after. Mass of trolley A times velocity of trolley A before the collision plus mass of trolley B times velocity of the trolley B before the collision equals mass of trolley A times velocity of trolley A after the collision plus mass of trolley B times velocity of the trolley B after the collision. So, mass of trolley A, 0.5, times velocity before the collision, 1.2, plus mass of trolley B, 1.5, times velocity before the collision. The exercise says it was stationary, so I get 0. Equals mass of trolley A, 0.5, times velocity after the collision. I just don't know which velocity it is, so I'm going to write V, plus 1.5 mass of trolley B times velocity of B after the collision. I write V again. Now, these two V's are the same because the exercise says that the two trolleys stick together after the collision. That means that the final velocity VAA equals VBA. The velocity of A and B are the same after the collision, okay? Now let's substitute values. So this is 0, this gives me 0.6 equals, and now I have two terms multiplying V. I can do, this is the same, writing this is the same as saying that is 0.5 plus 1.5, all of them multiplying by V, because if I expand this I get V times 0.5 plus 1.5 times V. So I just contracted this in here. So I get that 0.6 equals the adding of these two guys together, 2 times V. Therefore, V is 0.6 divided by 2. That gives me 0.3 meters per second. So that is the momentum, the velocity of the two trolleys as they stick together after the impact. Next question. 2A. A 1,000-kilogram rail wagon moving at a velocity of 5 meters per second on a level track collides with a stationary, meaning initial velocity 0, 115 kilograms wagon. The two wagons move together after the collision. So that means that their final velocity V is the same. Calculate the momentum of the 1,000-kilogram wagon before the collision. So again, momentum is mass times velocity. So 1,000 times 5, that gives me 5,000, and then the units are kilograms meters per second, okay? Second exercise. Show that the wagons move at a velocity of 2 meters per second after the collision. Now, some people get confused when they exercise instead of saying calculate, say show that. You need to do exactly the same. You just calculate the final velocity. And then hopefully it will give you 2, because that's what the answer is asking. So hopefully you did it right and you get what they're asking. So that's what I put it green. So again, we go and we pick our long equation. Okay, for some reason this is not changing slide. There we go. We pick the long equation. Momentum before equals momentum after. So velocity of the first one times the mass of the first one before the collision plus velocity of the second one times the mass of the second one before the collision equals velocity of the first times mass of the first one after the collision plus velocity of the first times the mass of the second after the collision. So substituting the values, 1,000 mass of the first times 5 velocity before the collision plus 1,500 mass of the second times initial velocity 0 because it was stationary equals, and then again I'm going to have 1,000 times V plus 1,500 times V. The two V's are the same, so I can get 1,000 plus 1,500 times V. So that is going to give me 2,500. So this side gives me 5,000. So velocity equals 5,000 over 2,200. That gives me 2 meters per second. Okay. I just got the same steps as in here, but I omitted this part. Okay. The rest is all the same. The last question, it says, a 3,000-kilogram truck moving at a velocity of 16 meters per second crashes into the back of a stationary 1,000-kilogram car. Again, stationary, velocity before the impact is 0. The two cars move together immediately after the impact, meaning their final velocity V is the same. Calculate their velocity. So again, I get the long formula and substitute the values immediately below. 3,000 times 16, the mass and the velocity of the first object before the collision, plus 1,000 times 0, the mass and the velocity of the second object before the collision, must be equal to 3,000 plus 1,000 times final velocity. And this is because it's 3,000 times V plus 1,000 times V. Again, I can do that because the final velocity will be the same for the two objects, okay? So the first part here gives me 48,000. This part gives me 4,000. So velocity will be equal to 48,000 over 4,000. That gives me 12 meters per second. And that's the answer. So these questions are pretty easy, to be honest. You just need to memorize the long formula or to understand the long formula, really, and then substitute the values directly below. You can also just calculate the momentum before, make it equal to the momentum after, But honestly, if you make this big formula, this is going to be useful for any type of momentum and conservation of momentum exercise. That's why I'm giving you this long formula, okay? May seem a little bit too much for now, but actually when you get to the other type of momentum exercises, you will understand why I'm giving you a general long formula where you can apply to any type of conservation of momentum exercises, okay? Now, quick quiz just to ensure that we know everything quite well, okay? So, what are the units for momentum? The answer will be kilograms meters per second. Next question. Which of these will not increase the momentum of something? So, momentum is mass times velocity. So, increasing the velocity increases, increasing the velocity in masses increases, decrease the mass does not increase the mass increases. So, is decrease the mass. Next question. The law of conservation of momentum says when two objects interact, the total change of momentum taking the direction into account is zero. So it's the first one. The second one doesn't say taking the direction into account. Third one says different to zero. Fourth one is just saying that it's different to zero and doesn't take the direction into account. So the first one is the right one. The best way to start an exercise on collisions. So you should write the momentum before and after, calculate, expand the equation, substitute the values and give the units. So it would be the last option out of all the options that show in here, okay? This one would not be enough for an exercise with collisions. This is not good enough because you're not getting full marks if the answer is wrong because it didn't show you're working. This one is not too bad, but remember that you don't know the momentum after or before, so it's better to expand the equation, substitute the value, give the unit. So this one is almost right, but remember, you need to expand the equation because you cannot calculate one of the moments, okay? So that's why is that last one. So that is it for conservation of momentum. Because this stuff can be a little bit difficult for some of you, I will have another video with more questions on conservation of momentum where I get other types of exercises as well. Up to my next video, be happy and healthy. Bye!